Page 3 of our study guide. So we're starting off page 3 with a little more factoring. So we still got to find the zeros, the x-intercept, y-intercept, and graph this. So same criteria to start this one out. First we check to see if we have any common factors that we can factor out. So first let's look at these numbers. So we got 2 and 50. So if you think about it, this is 2 can break down into 2 times 1. And 50 can break down into 2 times 25. So when we look at these factors, we know that we can factor out a 2 out of both of these. And now when we're looking at our x's, we have 5 x's on the left-hand term, and we have 3 x's on the right-hand term. So at least we can factor out 3 of the x's as well. So got quite a bit of factoring to do on this one here. Okay, so we're going to be factoring out 2x cubed, because that's the common factors that they had. And now we see what's left over. So I'm looking at this one here now. I factored out the 2, and I factored out 3 of the x's. So the 2's gone, which means 2 x's are left over inside. Minus, remember we factored out this 2. So all that's left inside now is the 25. And then these 3 x's, we factored it out right here. So there's no x's left for that second term. Now, we look to see this, we look at the term, the polynomial side, the parentheses. It's x squared, it's a quadratic, so we know that we can factor this. We just need to kind of determine how. And if we look at this, this is x squared minus 5 squared. So this here is a difference of squares. Remember difference of squares? Well, let me keep that on there. I'm going to bring this down. 2x cubed. And a difference of squares, when we go to write this, if we have this squared minus this squared, we write the same numbers inside the parentheses except 1 plus 1 minus. So we'll have x plus 5 times x minus 5. And keep in mind that when one is a positive 5 and one's a negative 5, that's what's responsible for getting rid of that middle term. Notice how we don't have an x to the first power there. Okay, and that's because the 2 parentheses, 1's plus 5, 1's minus 5, cancels out the middle term. So now we can find our zeros. So first we got to set this equal to 0. So 2x minus 3 equals 0. Oh, sorry, not 2x minus 3. 2x to the third power equals 0. So if we divide by 2, we get x cubed equals 0. Ultimately, we get x equals 0 with the multiplicity of 3. Next, we set this one, this parenthesis equal to 0. So if x plus 5 equals 0, subtract 5, we get that x equals negative 5. And if we do the same for this parenthesis here, x minus 5 equals 0, we get that x equals a positive 5. So there's our zeros. So our zeros are x equals 0 with a multiplicity of 3. We have x equals negative 5, and we have x equals positive 5. So our x-intercepts, 0, 0, negative 5, 0, and 5, 0. Okay, so let's graph those points. Not in white. Here's 0, 0, negative 5, 0, 5, 0. And our y-intercept, if we plug in 0, so we're plugging in 0 there, 0 there. As soon as you plug in 0, it zeroes out everything. And you can use your calculator to confirm this. But when you plug in 0, you get 0. So now our end behaviors, to determine that, we look at this term. It is the exponent odd, which means our endpoints our ends are going different directions, and our leading coefficient is positive. So we know we're starting down here. Starting down here, it goes through. It's going to through x equals 0. It's going to go through. And finally, x equals 5, it goes through. So when we go to state our ends, as x is going towards infinity, so x is going this way, our graph is increasing, so it's going to positive infinity. And then as our graph is going to negative infinity, so that way our graph is going towards negative infinity. Next question. So we have our function y equals negative 2x to the fourth minus 3x cubed plus 4x squared. Look at your coefficients. 2, 3, and 4. There's nothing we can factor out between them. So now we look at our x's. At least we have 2 x's, so we can factor out an x squared. So if we factor out an x squared, we're left with negative 2x to the second power minus 3x and then plus 4. So my a is not 1, so I can't go to doing the diamond yet. First we have to multiply these out. So we'll have x squared minus 3x minus 8. Now when we do our diamond, we ask ourselves what multiplies up to negative 8 and adds to negative 3. Let's see, we have 4 times 2 equals 8. 8 times 1 equals 8. And nothing else multiplies up to 8. And those don't have a difference of 3. So there's no numbers that can multiply up to negative 8 and add to negative 3. So we can't do the diamond method, which means we have to do the we have to use the quadratic formula. In the quadratic formula, I'll try to squeeze it in here. Negative b plus or minus square root b squared minus 4ac divided by 2a. So you want to label our a, b, c. Here's a, here's b, here's c. And we're going to plug it into our quadratic function. So starting here, starting at this negative sign, we're going to write the negative sign, plug in b, which is negative 3, plus or minus square root. B is negative 3, so negative 3 squared, minus 4 times a, which is negative 2, times c, which is 4. And then all this divided by 2 times a, which is negative 2. So now we have a bunch of simplifying we have to do. So we can simplify this here, we can simplify this here, and we can simplify these here, and the denominator as well. So simplifying all these out, I'll do it in this step here. Negative 3 is a 3, plus or minus square root. Negative 3 squared is 9. Now this here, negative 4 times negative 2 is a positive 8. Positive 8 times 4 is 32. So this is plus 32, all divided by 2 times negative 2 is negative 4. So I'm going to push this further and do one last step of simplifying. This step here, we can add those two together. So we have 3 plus or minus the square root of 41 divided by negative 4. So now we got to take this and we have to write two different equations for it. So we're going to split this. We're going to have 3 plus square root of 41 divided by negative 4. And then we're going to have 3 minus the square root of 41 divided by negative 4. So when we put these in the calculator, we get for 3 plus square root of 41 minus 4 for this one here, we get we get negative 2.35. So that is our 0. And for this one here, we get 0.85. And that is our 0. So when we go and write our zeros, we have x equals negative 2.35. We have x equals 0.85. And last, don't forget this here. This was also, right, so we only factored this portion here. That x squared is still kind of lingering out there. So this is x equals 0 with the multiplicity of 2. And that is also a 0. So now we got to plug those points in. Here's negative 2.35, 0.85, and 0. So if you look at our end behaviors, forgot to write the x-intercepts. Negative 2.350, 0.850, and 0, 0. See, y-intercept, if we plug that in, if you plug in 0, 0, 0, everything just zeroes out. So y-intercept is 0, 0. Okay, and then back to end behavior, we have a even leading exponent, which means the end behaviors go the same way. And since it's negative, it'll be opening down. So we know our end behavior is down and down. And now we just got to draw the rest of the graph. So at negative 2.35, we didn't have any multiplicity, so it goes through. At 0, we had a multiplicity, so it bounces. And then 0.85, no multiplicity, so it just goes through. And I probably should have made that graph a little wider, but still works. It's just a generic graph.